Oh.
All right, so this one, it says, at a given point, find the slope of the curve, the line that is tangent to the curve, or the line that is normal to the curve is requested. What? At a given point, find the slope of the curve, the line that is tangent to the curve, or the line that is normal to the curve as requested.
Oh, you got to find the slope of the curve. Slope at 1, comma pi.
All right, yeah, so we just got to find the slope at this point. So
Take the derivative.
this is implicit differentiation because we have x's and y's. We can't easily separate the y's. It's not that bad, but what I am going to do is I'm going to do it on a different screen, so somebody will have to tell me the problem, okay? So can somebody tell me the problem?
2x squared y.
Wait a second, it takes a second for my board to... Okay, so 2x squared y
Minus pi of cosine y.
pi of cosine y
Equals 3 pi.
equals 3 pi,
Slope at 1 pi. 1 comma pi.
1 comma pi. So this is the point that they're interested in. So this is a function, okay, and we want to find the slope that occurs at this point, right? So this right here is like an x comma y. Whoops. This is a point that occurs on that curve. So to find the slope, we got to have dy dx. That's what they want us to find. We don't know what it is yet. We're going to have to do implicit differentiation because the y can't easily be set by itself somewhere. So this first one, the 2 comes out to the front because that is a scalar multiplier. Okay, so this is a scalar multiplier. Then for this stuff right here, that's the product rule. So I'm going to take my first term, leave it alone, and then multiply it by the derivative of the second term, which is 1 dy dx. Okay, but for the product rule, I've got to add the reverse of that, which is the derivative of x, which is 2x, times the regular second term, which is y. So that's just the derivative of the stuff underlined or circled in red. This next one's pretty easy to differentiate. Let me make a little room over here. Pi comes out to the front because that's a constant, believe it or not. We treat it like a variable, but really it's a number. What is the derivative of sine? Or I said, what is the derivative of cosine? It's negative sign. So this becomes a positive, and then this is sine of y. Now remember, we could use the chain rule, right?
Good.
What is the derivative of y?
1.
1 dy dx. Okay? Now 3 times pi is still a constant. It's an irrational constant, but it's a constant nonetheless. So the derivative of this is 0. So now I'm going to push the 2 through the parentheses. And I get 2x squared dy dx plus 4xy plus y, or I'm sorry, pi sine of y dy dx equals 0. Next thing I'm going to do is I'm going to get all of the,
That's Tom.
okay, we're going to get, focus on the problem. Next thing we're going to do is we're going to get all the dy dx's on one side, so I'm going to say 2x squared dy dx, and then plus pi sine of y dy dx is equal to negative 4xy. Okay, I'll let that soak in for a second. Did I make any mistakes? No? Okay, good. Now I'm going to factor out my dy dx because I want to. That's what we're solving for, right? So I'm going to say dy dx times 2x squared plus pi sine of y, right, is equal to negative 4xy. You guys with me so far?
Yeah.
Am I doing okay?
Yeah.
Alright, so now I'm going to divide both sides by the stuff in the parentheses. So I get dy dx is equal to negative 4xy all over 2x squared plus pi times sine of y. Now what was that point that I wrote about a half hour ago?
1 comma pi.
1 comma pi, right? So that, remember, 1 comma pi is the x comma y. So this represents the slope, and this is the function that we're going to use. So I just need to plug in 1 and pi for x and y, and that'll give me the slope. You guys with me so far?
Yeah.
Okay. So then dy dx, which is the slope, is equal to minus 4 times x, which is 1, times y, which is pi. Then I have 2 times x squared, which is 1, plus pi sine of y, which is pi. Now, because you guys were excellent trig students and you had an amazing precalculus teacher, who can tell me what sine of pi is off the top of your head?
1.
1 pi.
Is it 1?
1.
0.
0. It's
Zero.
one or the other. How do you know?
Because you taught us.
Because sine wave,
How do we know?
from where it starts. It starts.
So without looking at your calculator, how would you find the answer? How does Mr. Adams always find the answer?
Graph.
Graph. So I'm going to make my circle, the standard circle, right? Unit circle, actually. And so here's my x, here's my y. And I'm going to go like this. The unit circle means it has a radius of 1. And so when we use the unit circle, we think of x comma y as what?
1.
Cosine comma sine. What am I looking for?
Sine of pi.
Sine of pi. What is pi in radian measures? Where's that end up on the
180 degrees.
180 degrees. So what I'm saying is, if I come around starting from the initial side here, and I come right here, what is this point on the unit circle?
0.
0.
Negative 1 comma 0. What is sine of pi?
0.
0.
So,
Double check it in your calculator real quick.
I got you.
Well, that's what the answer is. So anyways, this whole thing goes away to 0. Because 0 times pi is 0. So dy dx then is equal to negative 4 pi
All over 4.
all over, it's not over 4. What do we do first?
Oh,
1
1. It's 2.
squared
It's
times
2.
2 or
2.
negative 2 pi. Whew, that was a lot of work. Now,
Yeah.
before I move on to the next slide, does anybody have any questions? Because we got to go back and see if that's the right
Is there
answer.
going to be a
It
problem
is.
exactly like this on our test?
Exactly like it on the test. Different numbers. Different numbers.